Hi.
Hi.
Start our discussion. Do you have any doubt? Have you gone through the previous chapters and all those things?
Yeah, I understood
Okay.
that. Yeah.
Are you facing any difficulties in those things?
No. It
Okay.
just
I
I
was
got.
going through your
Oh
use
yeah.
use paper. I am able to solve right now. I got time, so I got 5 to 6 questions. I solved it roughly, and
Okay.
I will send you the solution meanwhile. Okay. By today or
Yeah.
by tomorrow, I will give you the solution. Okay.
Thank you very much. Yeah.
I will give you. If you want to discuss any specific question on that one, we can discuss it. Otherwise, we
Yeah.
can
I'll
move.
probably after you send me the solution, I'm gonna because I have
Right,
to.
right,
So I'm
right,
gonna
right. That will be
solve
fine. That will
them.
be fine.
Yeah, and then
Yeah,
probably next week I'll ask if I have any doubt.
yeah. What I
Thank
will
you.
do, I will give you the solution, and you should go through those solution. If you'll
Yeah.
find
Yeah.
any difficulties, you will let me know. Okay.
Yeah.
Okay.
Okay.
This week I will give you. Okay.
Mm-hmm.
Okay. Okay. Let's start our discussion. Okay. Okay. Just give me a minute. My screen visible to you?
No. Now it is.
Okay. Good. Just a minute. We had completed the first notes, right? First notes that you have given to me.
Yeah.
Till PLL, we completed it. Okay. Okay. I will start with the second notes. I think we did covered couple of things in the second notes.
Mm-hmm.
Direct synthesis problems in PLL. Those things we covered it. Applications in PLL. Yeah, we will start from transmitter design. Okay.
Okay. Yeah.
Okay. New topic. Start from scratch. Try to understand. Any doubt, let me know.
Mm-hmm.
Transmitters in design. Okay. What is transmitter? Transmitter are those devices through which we use to send our signal over a channel, and we receive that signal using a device known as receiver. Okay. So what does transmitter? Transmitter transmits the signal. Okay.
Mm-hmm.
So what should be the characteristics of any signal? Any signal, if I am telling you a signal has a different frequencies. Okay. Suppose in the frequency domain, if I'm considering a signal, so F1 frequency, F2 frequency, there are many harmonics. And we are interested to the power component at these frequencies. Okay. Suppose this frequency, this much power, this much power. So we will concentrate on the power of the of the frequency component. So major important part in our transmitter design is power and frequency. Okay. Power should be it should be as much as, so that we can, suppose we have a transmitter here. If our signal power is very less, it will not reach to the destination point. So power should be very good. power should be as much high as possible. Okay, and frequency is dependent upon the power. Okay, so what is the transmitter requirement? First requirement is power. So it must produce the required output power that is required for broadcasting. Okay, it can be 1 kilowatt for the broadcasting purpose, and 1 milliwatt for the short range device. If just like Bluetooth, in Bluetooth, what happens, we used to transmit the data from one mobile to the other mobile. So in that case, that we require the very less transmitter power. 1 milliwatt will be sufficient. But
Mm-hmm.
suppose if wants to transmit the signal over a channel over a longer distance, so transmitter power will be very high. Okay, so first requirement of a transmitter design is power. Okay, power depends upon whether we are broadcasting or we are doing the short range service. So in that way, power is defined, or power requirement will be there. Okay. Second is the frequency. There can be the different frequency component. So second is frequency. Okay. Okay. And third important characteristics is minimum unwanted emission. Frequency will determine the bandwidth also. Bandwidth is also important. Bandwidth, what is bandwidth? Bandwidth is the range of the allocated frequency. Okay. Just going to the frequency allocation part. Frequency spectrum this is the frequency spectrum that is often allocated. If we are working in this frequency 470 to 860 around megahertz, it will be used for TV broadcasting. 880 to 915 megahertz or 925 to 960 megahertz is used for GSM, and above 1.2 is 15 gigahertz is used for GPS. So generally this may come in your quizzes also, that from 880 915 megahertz and from 925 to 960 megahertz GSM. GPS above 1.2 1.5 gigahertz. Okay, and an example of GSM 900, they have taken an example of GSM 900. In this, they are telling that we have the uplink band. Uplink are those frequency that we are using for uploading. Okay. Uplink band is 890 to 15 megahertz, and downlink band 935 to 960 megahertz. Okay, these are the uplink band and downlink band. How does these works? Uplink band, and actually the things is working like that. Suppose this is our uplink band 890 to 915. Okay, what is the band gap between this one? 915 minus 825, that is 25 megahertz band. Okay, now now we are allocating channels to into these bandwidths, into these band gaps. Okay, and if the channel spacing is generally, this is the standard way that channel spacing are 200 kilohertz. Number of channels allocated equal to FH, higher frequency minus lower frequency, divided by channel spacing minus 1. So can you tell me how many channels can we allocated here? Can you tell me?
Just a second. So
See, first try to understand the question. Okay.
yeah, I know. I'm just writing down.
Okay.
Is the
You
channel
understood this?
is channel spacing in kilohertz or megahertz?
Yeah, right. It is 200 kilohertz.
And okay.
And it is 25, and this is 800. This is in megahertz, right?
Yeah. So it's 114.
Sorry?
114 number of channels.
100, no. What is FH minus FL? It is 25 megahertz, right?
Oh, I put 23 megahertz.
25. Channel spacing is 200 kilohertz, right?
That's fine. I put 23 instead of 24.
It will be 25, right? 25 megahertz.
124.
Right. Okay.
Yeah.
Okay. Okay. This is the uplink. In the uplink band, we can have these number of channels allocated, right? In the downlink band also, because I told you that in downlink band is 935 to 960 megahertz. So downlink band has also a frequency that space, that gap between higher and lower is 25 megahertz. So here also the number of channels that can be allocated is 25 megahertz. Okay, so they can 125 number of channels. So they can ask you question that considered a GSM system. Okay, and calculate the number of channels allocated in that system. So you have to remember these bands also, right? That uplink bands for GSM is 890 to 915 megahertz for GSM 900, and downlink band is 935 to 960. Okay, are you getting my point?
Yeah. Could I just ask something?
Yeah.
So So why do we need to allocate channels in between these?
Yeah, very good question. Suppose I have for one communication, I have allocated these number of bands to you, bands for TV. Okay,
Mhm,
assume this is GSM is for mobile communication. Okay,
mhm,
890 to 915 megahertz is allocated for mobile communication. Okay, and
mhm,
do we have only one channel? There are very several channels, right, in mobile communication. So each channels must have some of the its band. Are you getting my point?
mhm,
Because these are the bands, because we have the frequency from 1 hertz to 100 gigahertz and very high also, right? But
mhm.
we have many applications like mobile communication, radio communication, TV broadcasting. So we have to allocate different bands of frequency for different type of communication, right? We
Mhm,
have allocated 890 to 915 for mobile communication using GSM. Okay.
mhm.
And in that mobile communication, we have several users. You are also using the same
Mm,
frequency band. I am also using the same frequency band. If we
yeah,
will not allocate different channel space to each individual, then our frequency, my frequency will get overlapped with other frequency.
yeah, yeah,
Interference will happen. So
yeah,
to avoid interference, we are allocating a certain channel to each individual. Okay, to each channel.
yeah, yeah. I
Okay,
understand.
understood. Okay,
Mhm.
okay. Okay. Let's see then. After that we have a GSM emission, that is spurious emission, intended emission, frequency tolerance, that is the other thing. Adjustment, that is also example wireless LAN. Band is 2.1 in most time divided number of 3 channel. Do you know what is EIRP?
Yeah. I feel like I've seen it before, but I can't remember.
Effective iso isotropic radiated power. Okay.
Mhm,
If you see your today the quiz paper that you given to me, here there was a lot of questions from ERP. ERP is PT into GT. Okay.
mhm.
Transmitted power into transmitted gain. Okay. 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 I'm just drawing a figure to you, and you have to tell me the bands and bandwidth of the channel. Can you tell me what is the bandwidth of this channel?
Is it around 22
Right,
megahertz?
right. It will be around 22 megahertz. Okay. 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 These are the just basics of the bands and frequencies. We will start now with transmitter, how the transmitter works and how does we are doing the modulation and all those techniques in transmission.
Mm-hmm.
Okay. And have you got the second quiz also, or only one quiz you got?
Um, I have no, I don't have the second one. I'm gonna do the second one next week.
Okay. Okay. Till then, you will get ready with the first one, right?
Yeah, but the second quiz is like a different topic.
Yeah, different. How many
Yeah.
quizzes will be there?
4.
Okay, 4 quizzes. 4 week, 4 quizzes. Like that? Is it like that?
Yeah, like I have a deadline, like when to do each quiz. Like I can choose my own time,
Okay.
but yeah,
When your exam, final exam?
20th of December.
Okay. Questions will be like the quizzes question, right?
The exam,
Yeah, exam.
not really. I think did I send you? It
Yeah,
will
yeah.
be like
Paper.
yeah,
You sent it me.
yeah.
Yeah,
It's gonna
you
be
sent.
like a that.
Okay. Okay. Will the quizzes will not help you? Or it will.
I think the quizzes are just for practice,
Okay.
a little bit, but yeah.
Yeah, but they will use same concept, right? Whatever they are asking in quizzes, right? Same topic the same topic they will ask, right? There
Yeah, it
also.
will be the same topics, yeah, but it won't be the same questions. I feel like the questions will be more
Yeah, yeah, yeah. Question will be
complex,
more.
yeah.
Yeah. And we will slowly start doing the previous paper also. Okay.
Yes, that's good.
From next class, what I will do, I will take up 2 3 questions from each paper and we
Mm-hmm.
will start doing. Okay.
Yeah, that's
That will be
perfect.
also good. Okay.
Yeah,
Side by side, we can do the those things also.
yeah,
2 3 question every day, likewise.
yeah, perfect.
This is your transmitter. Okay, okay.
Mm-hmm.
Transmitter is doing what? First, we are getting a signal. Any signal that we are receiving, that is our baseband signal. Okay. Those
Mm-hmm.
signal are getting passes. Okay, passes to the modulator. What does the modulator? Actually, the baseband signal is nothing but the signal around this center frequency is zero. So these frequencies values are very less, and lesser frequency do not travel to higher distance. Okay, if my frequency value is less, so it cannot travel longer distance. Okay, so we for if it's tended to travel the longer distance, we have to choose a very high height of antenna height will be very high. Just like I'm giving you that height of generally height of the antenna is lambda by 4. Okay. And if my frequency is suppose 10 megahertz, 10 megahertz or 10 kilohertz, let's say 10 kilohertz, then our lambda will be 3 into 8 into 10 or 4. It will be 3 into 10 or 4 meter. So my height of the antenna should be 300 into 4 into 100. So it will be around 75 meter. So 75 meter is a very high length of antenna, very big number. So
Mm-hmm.
to reduce this antenna height, or to have the transmission more efficient, we are increasing the frequency. We are increasing the frequency. How we are increasing the frequency? If we will increase the frequency, the height of antenna get drastically reduced, because height of antenna is inversely proportional to frequency. If
Mm-hmm.
frequencies are increases, are being increased, height of antenna will get decreased, and we are having the good transmission of the signal. Okay, so what is the way for reducing the height of antenna? To reduce the height of antenna, we are using the modulation. Okay,
Mm-hmm.
so if we are having a baseband signal, we are modulating the baseband signal with a higher frequency local oscillator carrier signal. This is the FS. FS is a local oscillator carrier signal. Okay, so
Mm-hmm.
we are modulating this signal using FS, and we are modulating it. So my frequencies are being modulated. Low frequency components are being modulated. Okay, in this way the modulation happening, and this modulation are and these are the amplifier. These are nothing but amplifier that are boosting the signal level. These are the amplifier that are boosting the signal level. So in this way, communication is being happening. Okay. Do you have any doubt that how the communication is being happening? You can see this frequency was low. You can see this frequency was low. Now at this, the frequency got shifted till here. Are you getting it?
Mm-hmm.
So here for doing the transmission, we have increased the frequency, and transmission is going to happen, and efficient transmission is happening here. Are you getting my point? Do you have any doubt?
No, that's fine.
Okay. Yeah, simple transmission signal carrier adjustable gain. Yeah. One thing more. Have you ever heard AGS, automatic gain control? AGS, AGC,
No.
adjustable gain control. See, in our day to day, in our life, when we are sending a signal, or suppose you are talking to me, you are you are speaking near your microphone, right?
Mm-hmm.
Right, and the signal being transmitted through your microphone over the channel, and it is reaching to me, right? Right,
Mm-hmm.
so since you are sending a mm, sending something, sending some information to me, a part with the information you are sending, uh, the noises can be also added into your signal, right or wrong?
All right.
Right, so sometimes sometimes the noises will be more, and sometimes the noises will be less, right?
Mm-hmm.
So suppose the time when noises become very high, your original signal get distorted,
Mm-hmm.
right? original signal get distorted, that means we will not able to hear the original information, right? In that way, we have one device known as AGS, adjustable gain control. So as the noise is increasing, the information signal amplitude is also getting increased. So it is maintaining that ratio, that signal to noise ratio, that is required for a good communication, that is required for efficient communication. Okay.
Mm-hmm.
So that the adjustable gain control is doing. Okay.
Mm-hmm.
Okay. Or if we can understand in that way, the adjustable gain controller, it adjusting a noise in such a way that so that signal to noise ratio will not get deteriorated, and we will get trans efficient transmission of the signals. Are you getting my point?
Yeah.
Any doubt?
No.
Very good. Just give me 1 minute. तो एक लड़का ही दौड़ सकता था सच्ची में। फिटनेस के अलावा एक बात की जब बॉडी फिट है वो डिजर्व करता है, इसकी बन जाती है रिकॉर्ड्स डिजर्व करो अपनी कंफर्ट जोन से। This is the adjustable gain control. After just now I told you that for a transmission, for efficient transmission, we are doing the modulation, right?
Mm-hmm.
So now we will study the modulation scheme. What modulation we are doing? Okay.
Yeah.
We are doing the quadrature amplitude modulation. What do you mean by quadrature amplitude modulation? In quadrature amplitude modulation, we are changing the phases of the message signal and amplitude of the message signal to have the efficient transmission of the signal. Okay, the quadrature modulation looks like that. This is digital to analog converter. Here it will be a filter or amplifiers. Okay, here it will be have in phase component. Okay, so what is happening? We are here. We are having the in phase component here and quadrature component here. So in phase component is getting, and this is our FS. This is our local oscillator, and this is the shifted local oscillator. So it is basically it is cos 2 pi FC FST, and this is sine 2 pi FST, and we will get here IT cos 2 pi FST minus QT sine 2 pi FST. Okay.
Mm-hmm.
So QAM needed by many digital modulation schemes. We have two baseband signal, I and Q. We are have actually every signals we have a signals, just like in phase component. We are picking the in phase component and quadrature component of the signal, passing from digital to an analog converter, and we are doing the modulation of the signal. Okay.
Mm-hmm.
Now, okay, this is the QM modulation that we are using in our this technique. After the next topic is frequency shifting. We will look closer to this one. Okay. Have you had, do you know the, okay. If I'm multiplying two frequency component, A1 cos 2 pi F1t and A2 cos 2 pi F2t. Or can you tell me, if I want to shift my frequency, suppose my frequency is F1, is at F1. And if I want to shift my frequency to F1 plus F2 and F1 minus F2, what I will do?
Mm,
Okay. For shifting, for shifting a frequency, what we are doing, we are, if we will multiply two frequency component, two signals, or of having different frequency F1 and F2, the signal get shifted. The frequency gets shifted by other component. Similarly, if we have our input as A1 cos 2 pi F1t, and if I want my signal at F1 plus F2t, so I will multiply my signal with another signal cos 2 pi F2t, and my signal will get automatically shifted to this one. Okay. And
mhm,
suppose if I will choose air high pass filter, I will get here A1 cos 2 pi F1 plus F2t, because this will make it A1 plus AY2 cos 2 pi F1 minus F2t plus cos 2 pi F1 plus F2t. Okay.
mhm.
Okay. Now move a signal to different frequency. Okay. Let's take up a question now. Okay. One question. Can you tell me which frequency component I will multiply here so that I will get the output here? Can you tell me? This is my input and I want my output like that. What should I do?
Um,
Think for 2 minutes. Yeah. Are you trying to understand it? Are you
Mm,
trying to do it?
I think I just
Yeah.
need to shift the signal, right?
Yeah, you have to show the signal. You have to tell me the signal.
Um, so I think the amplitude and everything would be the same.
Okay, I'm not talking about the amplitude. I'm talking about the frequency component.
Um, I don't know, maybe phase. Change the phase.
No, I wrote in the first step only phase will not change.
I don't know then. I don't know.
You're not getting.
Mm-mm.
Okay. Let me try to explain you once more because I want answer from you only. Now look at this. See, I told you A1 cos 2 pi f1t, right? If I'm multiplying with another frequency component A2 cos 2 pi f2t, I will get component as A1 A2 cos 2 pi f1 plus f2t plus A1 A2 cos 2 pi f1 minus f2t. Okay. Now see, just pick one frequency component here, 44. Okay, pick 44 only. If this is 44 f1 and here I am getting this highest component as 784 and this as a 864 and this as a 784. So what does it mean? It means that f1 plus f2 is 864 and we have f is 48 42 864. So can I tell it will be 820 or not? Are you getting my point? If you shift this signal by 820, you will get this signal only. You can see here. If f2 is 820, you will get these one only. Everything will get shifted by 80. By 820, you will get 864 and 856. And here every six signal will shifted by minus 820. Okay, are you getting my point?
Okay.
Okay. So in this way, you should be in that position that you can answer this type of question. Okay. What are the different frequencies component that can be achievable? Okay. Let's see here the next step. Okay. Okay. Now another question. These are the important questions this time. If my input signal is 36 and 44, okay, these are input. This is my filter. This is my mixer. I am giving input, and these are my oscillator, that megahertz. Okay, these are my input, and now I am giving the output. My output is 856. 864, 776, and 784. Now, question is given that it is, we want one component as 860. 860 is my component. These signal, are you getting my question or not? These is my input signal. Okay, I am multiplying my this signal with 820 megahertz local oscillator. I will get these at this point, right? These two signal component. Okay, now they are telling that at output we want only this signal component. So can you tell me which filter I will use? Okay, can you tell me which filter I will use?
Um, high, low pass filter.
Mm, only one component output is one, assuming it is component 860 megahertz. No, low pass will not will. It will be the high pass filter.
Mm.
It will be because we want the high frequency component, right? So high
Yeah.
frequency component will be given by high pass filter only. Okay, are you getting my point?
But how do we get, if we, from the first signal, when we multiply it,
Yeah,
how do we get two
yeah,
signals?
yeah. That only
How
I
do we,
told you. Yeah, that I only told you. Suppose this topic was that only, frequency shifting. Suppose my frequency is f1 and I want to shift my frequency to f1 plus f2 or f1 minus f2, or you can take it in this way, opposite way. I want to shift my signal to f2 plus f1 and f2 minus f1. Then what we will do? We will multiply this frequency component with another frequency component having the frequency f2. Okay, it means that suppose a signal a1 cos 2 pi f1 is my input. Okay, this will give you f1 frequency, right? I will multiply this signal with another frequency component a2 cos 2 pi f2t. Okay, now can you tell me a1 cos 2 pi ft and a2 cos 2 pi ft using trigonometry? What does it mean? Can I write it a1 a2 by 2 cos 2 pi f1 plus f2 and plus a1 a2 cos 2 pi f2 minus f1? Can we write in this way or not?
yeah.
Can we write? Okay. So these are the frequency component a1 cos 2 pi f2 and a2 cos 2 pi f2t. These are the two frequency components and we are getting output this one. Okay. So in this way, we will get the different frequency component. Suppose f1 is this one. F1 is a signal that is in this one 36 to 44. So we will multiply with f2 in such a way that this signal gets shifted to f1 plus f2, and f1 plus f2 was 856 to 864 and f2 minus f1 was 776 to 784. Are you getting my point? So we
Mhm.
can find the f2. F2 will be 820. Are you getting my point or not?
Yeah.
Yeah, these was good examples. Okay, we'll conclude till here. Not today. Frequency shifting we did. Now sometime we mix F1 then to Fs. Okay. Okay. What is happening for here? Okay, this is also the same. Digital QM now. We can see the digital QM. Okay, digital QM is also same. Yeah, can you open this PDF
Yeah.
and can you go to the page number 33?
What page does it say on the slide?
Yeah, okay. On the slide, the page number is 15.
15. Okay.
Okay. They can ask you these diagrams also. Okay. Digital QM, like those things. So you have to tell me whether you are able to you are getting these graphs or not. These block diagram or not. If you're not getting it, then you have to let me know.
Uh, can you explain to me?
Yeah. I have explained these block diagram right away to you. Just
Mm.
last block diagram was that only. See, I'm just explaining you once more. See, we have F1 frequency at the input, right? In the page number 14, at the leftmost part, the red arrow is showing one component F1, right?
Yeah.
Okay. We are multiplying another oscillation frequency F2. Okay.
Mm-hmm.
Okay. Are you getting it? We are
Yeah.
multiplying F1 with F2, right?
Mm-hmm.
And we are getting Fs, right?
Yeah.
And Fs is what? Is nothing but F1 plus F2, right?
Yeah.
So basically what is happening?
Why
We
is it
are,
why is
yeah,
it F1 plus F2 if we're multiplying?
yeah, because just now I told you, right? If we are multiplying two signal, right?
Yeah.
F1 and F2 of different frequencies, it will give the two frequency component F1 plus F2 and F2 minus F1, right?
Yeah.
Right or wrong?
Yeah.
Okay. So, but we are passing it to high power, high pass filter.
Oh, okay, okay. So after the half pass filter.
Yeah. So we will have only one frequency component, right? F1 plus F2.
Yeah.
Now, now,
What is the symbol for the filter?
yeah,
Is it
that is the
the
symbol
wave?
of the filters, symbols of the filters and amplifiers and all those things.
I know.
Okay.
I'm just saying, is the symbol for the filter the one with the waves?
Right, right, right. Okay.
Yeah.
Now my question to you, if I am replacing my high pass filter with low pass filter, which frequency component will pass?
Um.
What will my Fs?
Um. F2 minus F1.
Right, right. Okay. Any doubt? Because they can twist the question also, right?
Mhm.
Okay. Any doubt here?
No.
Okay. Now can you observe the page number 16?
Yeah.
Okay. Now can you tell me what is the gain of this amplifier, of this curve? Can you tell me the gain?
Okay. The gain is 5.
How the gain is 5? Can you tell me?
Isn't it output power over input?
Right. What is output power?
25. I don't know if I take like at, for example,
So you can take at any
if
input
I take
power.
at input power of -5, it would be.
Yeah.
Oh, you mean like it's -5?
-5. So it will be 30 dBm, right? Are
Yeah.
you getting my point or not? Around 30 dBm, because exact values is not there. It can be 28, 29 also. See, what is gain? Just tell me. Gain is P output by P input, right?
Mm-hmm.
If observe as at when input is, when P input equal to 0, what will be the P output? When P input is 0, P output will be
30.
around 28 or 30, right? I can write approximately
Yeah.
around 30,
Yeah.
right? dBm. So what will be the gain then?
0.
Okay. So gain will be what?
0.
P output minus P input,
Oh.
right? Because it is in dBm, it will be
Oh.
30 minus 0. It will be around 30 dB, 30 dB. If we will subtract dB, dvm, with dvm we will get db. Are you getting my point?
Mm-hmm.
So this type of question can be asked. Okay.
Yeah.
Are you getting my point?
Yeah.
Can you go through page number 14, 15, and 16 in 2 minutes and tell me if you have any doubt?
And page 15, can you explain the digital signal processing part?
Okay. Yeah, 1 minute. Let me go to that page. Page number 15. What are you telling?
The
Digital?
the blue part.
Okay. The blue part is nothing but the circuit. Okay. So in the first one, what they were doing, they were directly inserting the analog signal. Okay. You know analog and digital signal, right?
Yeah.
Right?
Yeah.
Analog signal, the continuous signal, okay? The signal that varying with the time, right? These are
Mm-hmm.
the analog signal, right? But the digital signal is like that. 0 1 0 1, likewise. Okay. So here what they are doing, they are just first they are converting the digital signal to analog signal, and rest part are same. Are you getting my point?
Mm-hmm.
Okay, first block are digital to analog converter. Okay, any doubt?
No.
They are doing digital modulation here. Okay, now you can observe the page number 17.
Okay.
Okay, in the page number 17 you will see the result signal distortion. In 16 QAM you can see we will have the 16 different possible values. Okay, and in AM we have only 4 different possibles, and in AM and PM we have only 4 different possible values, but in 16 QM we have 16 possible values that I want to show you. Okay, after that, transmitter design. Observe page number 18, 19, 20. Likewise, if you have any doubt, then because I have explained this thing. Okay, any doubt?
No.
Okay, then wait a minute. Let me see. Can we do some questions? Can you take open the question 2018-19?
Yep.
No, no, you can open in your phone. I will just detect you.
Have it.
Yeah. Can you go to the question number 2?
Mm-hmm. The radio transceiver.
Right. Okay.
Okay.
Okay. Okay. Now read the question with me. A radio transmitter is being designed using frequency division multiplex. Okay. Transmitting at a frequency in the range from 1920 to 1980 megahertz. Okay.
Mm-hmm.
80 megahertz. While receiving a frequency at 190 megahertz higher than the transmit frequency using the same antenna. This is your transmit frequency. Okay. And they are receiving the frequency 190 megahertz higher than the transmitting frequency, right?
Mm-hmm.
So they are receiving at 190 higher megahertz, right? Then I will add 190, 1980 plus 190. What will be the value at the receiver side? It will be 2170, right?
Mm-hmm.
Are you getting my point?
Yeah.
Or it will be 2110, right?
Mm-hmm.
I'm just decoding the question. Okay. Are you getting my point?
Yeah.
Hello?
Yes. Yes.
Okay. Till this, you are clear, right?
Yeah.
Okay. The channel bandwidth is 5 megahertz. Okay. It means that here we will have a many channels. Okay. Channel bandwidth is 5 megahertz. So can you tell me number of channels? Can you tell me this minus this, right? 60 divided by 5 minus 1, right or wrong? Can you tell me number of channels? You have to tell me because I told you today how to find number of channels.
No, but the one it's the easy.
Can you tell me? Sorry?
It's 11.
Hello? Yeah, it's 11, right? 980 minus 920 divided by 5 minus 1, it will be 11 channel, right? Okay. Now the modulation is QM, quadrature amplitude modulation. Okay. Now they are telling in the transmitter, the modulation will be performed using digital signal processing with the modulated signal passed through one digital to analog converter. Pass to digital to an analog converter. Okay. After that, we will have in phase component that will be mixed with one signal component. Okay. This is also digital to analog converter that will give you quadrature component, 90-degree phase shift. Are you getting my point? Are you getting or you have any doubt? What I am doing, are you able to get, are you able to understand? Are you getting it or not?
How do we know it's a 90-degree phase shift?
Yeah, because in phase component and quadrature component, and they are telling that it is quadrature amplitude modulation we are using. So just now we learned how the transmission is happening there. Right? If you open the slides, page number 10, page number 10 or page number 14, page number 15, there are everywhere they have given that figure.
Okay.
Okay. Are you getting my question? Are you getting my point? If you have any doubt, you can ask me. Are you seeing the page number 15 and 14 of those of your
Yeah.
slides? There we have the QM modulation filtering technique, right or wrong? This type of
Yeah.
figure, right? Right?
Yes. Yes.
Now, we'll perform this with the modulated signal through digital, which can operate at maximum sample rate. This is digital to, and this sampling rate is 150 mega samples per second. Design the rest of the transmitter and draw the block diagram. This is your block diagram showing your design. In particular, choose a suitable sample rate. What will be the sample rate? Can you tell me what will be the sample rate? We can choose a sample rate. If we have fs is 150 mega sample per second. First of all, tell me what is the here bandwidth. Here bandwidth is fm. Here bandwidth is our band is 60 megahertz, right or wrong?
Yeah.
So we can have what is the minimum sampling rate? Can you tell me? Minimum sampling rate is always 2 into band. Okay. So it will be 120 mega sample per second. Are you getting my point? So my sampling rate will be anything between 120 to 150. You can choose any sampling rate. Are you getting my point?
Yeah.
Okay. So we choose a sample rate that can be 122 between 150. Okay. Now draw the block diagram showing your design. I draw the block diagram. In particular, choose a sample rate. Also, important properties of each filter that you use. Okay. So these signals are then transmitted using high pass filter, right? Right or wrong? We will have many amplifier there, but after that we will pass it using high pass filter, right?
How do we know?
So what are the advantage of high pass filter? You can write that advantage of high pass filter that it will pass only high frequency component. Right or wrong?
Yeah.
Right? So
But
specify each and frequency.
do I usually want
Sorry.
do I want high frequencies or low frequencies?
Yeah, we want high frequency because in your question it is given clearly that you want at receiver 190 megahertz higher than the transmitter frequency. Is it given or not? If you read the question number 2 statement, is it given
Yeah.
higher than the transmitter frequency? It was given. So what frequency we will use? High
High,
pass or low pass?
high pass.
Can you tell me?
High pass.
High pass, right?
Mm.
Okay. Now, yeah, high pass. Okay. Now they are asking this frequency also, local oscillator frequency also. Now you tell me, I am changing my 1920 to 2110. Okay. So what will my local frequency, LO oscillator frequency? LO oscillator frequency will be nothing but 2170 minus 19880. That will be 190 megahertz. Are you getting my point?
Mm-hmm.
Are you getting it or not?
Yeah.
Okay. This was your answer. Okay. We
But
did till receiver, till transmitter here. So that's why I am just doing the question number 8. Okay.
so
Hello.
I just want to ask, um,
Yeah.
so
Your voice is getting breaking.
in this picture, one arrow is going up and then one arrow is going down from the 90 degrees. But in the figure, it
Right,
not.
right, 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 right.
And and it says in the question, specify the important properties of each filter that you
Yeah.
use. Would
You
that,
can use a high pass filter here,
what
right?
do I not need to give more details or something?
Yeah, you have to give detail that high pass filter are, you can write in there high pass filter. You can draw the graph of the high pass filter also. High pass filter graph looks like that. Okay. High pass filter blocks the lower frequency component. It allows only high frequency component to pass. Okay. Any doubt?
No.
Okay. And question number 1, those things we did already, but I will help you in solving those questions also. Okay. There is
What
no
about
issue.
B?
B part is a receiver. Till now we studied only transmitter,
Okay.
right?
Yeah. Okay.
We have today we study transmitter only, right? So first we will study the receiver. After that we will do that one.
Yeah.
Okay. Similar thing is there. Just there you have to draw the receiver block diagram. Okay.
Okay.
Okay. And they are telling that it is not necessary to give the same level of detail as for transmitter, but you
Mm-hmm.
should explain where and what frequency channel selection is performed and how interference from transmitter is avoided. You have to write all those things. Okay. That we will study it and we will add it. Okay. Till now, are you, I chosen this question because today we studied this concept. So that's why
Yeah, yeah,
I
yeah.
tried
That's fine.
to I tried to explain. Yeah. Okay.
Yeah.
Okay. If you have any doubt, then we can again discuss this one. Tomorrow again we are meeting at the same time, right?
Yeah.
Okay. Okay, then see you tomorrow. Okay.
Okay. Thank you.
Okay, bye.
Thank you. Bye.